Hello, everyone. My name is Jose Villarroel. I am the lead animation engineer of the animation gameplay team at Epic Games. Uh, I'm very happy to be here, and thank you for being here. This is actually my first trip to Europe, so I am really grateful that I'm in such a beautiful city. And also, I heard there was a little bit of a mix-up yesterday. They had like a sign that said motion matching on a different talk. If you're curious, this is the right one, so let's get that started. So today I'll be talking to you about motion matching and the game animation sample in 5.4. So let's start with motion matching. Just a quick summary of the technique. It's what we're showcasing in the game animation sample for now. Motion matching is a query-based animation selection system. There are three things that we care about here. First is the query. The query is divided in two things. First, what the game wants, represented in blue. In this case, it's a trajectory. That we're trying to tell motion matching this is what we want to do. And then the second is the current state of the system, which we can call it the pose and also the trajectory of the previous animation. Right here, you can see it with the lines that are drawn on the feet and the trajectory of the currently selected animation. Next up is the database. Now that we know what parts of the pose and the current state are what we care about, we want to select an animation that most closely gets us to our game's desired state. So we just search the animation that closest matches that, and we get a result. And we will find the result that most closely gets us to that original query. With that out of the way, let's talk about the game animation sample. The game animation sample was released, I think, 1 week ago, and we know that a lot of people liked it, so that's why I'm here to talk about this today. The game animation sample is a high-quality gameplay animation showcase. And we want to emphasize that it's a living and breathing sample. What this means is that on every major engine release, we're gonna give you an update of stuff that is worthwhile to look at. Also, this particular release, we didn't align. We released like a few months after, so sorry about that. The next one we will release in time. Then the next up is our focus on quality. There's a lot of documentation and tutorials out there. A lot of them are community-driven, excellent tutorials, but those will only get you 70% of the way there. This presentation and the game animation sample is about that final 30%, which is really hard. And also, the sample is not a full game. What that means is that we're not implementing like UI systems, there's no inventory. This is all about animation selection, how gameplay feeds data to your animation context. And finally, we want this sample to be flexible and self-contained. And this is a promise. What I mean with this is that you can grab individual pieces of the game animation sample, put them in your project. We've seen a lot of people from the community do that in their own projects to great success. And most importantly, so that you believe me, we do that ourselves. A lot of our internal projects, they start on the R&D phase by grabbing the game animation sample, dropping it in, and starting from there. And the process is not perfect right now, but we're going to improve it with upcoming releases. So this is what I'm going to be talking about. And for the rest of the presentation, except at the end, it's going to be a live demo. So if I get crashes, I'm sorry, live demos. Here we go. So let's start with that 70% that I talked about before. We're going to make a motion matching setup from scratch, like right here. The first step is you need your animation blueprint. You drop a motion matching node, pose history, you plug it in. I'm going to tell my pose history to auto-generate our trajectory, so I don't have to do anything else. And there you go. That's my graph setup, nothing else. Now, I'm going to make a pose search schema. So when I was talking before about what you care about in your pose or what the game is doing, that's what the pose search schema is about. You are defining everything that you care about in your animation for selection. In this case, we auto-generate one for you that's pretty solid. It's basic, but it works. And what you care about here is really channels. First is the trajectory channel that represents how much you care about your selection matching the game's desired trajectory. And second is your post channel. Post channel represents how much you care about the new animation matching the previously selected animation. In this case specifically, we care about the left and right foot, specifically positions and velocities. So that's it. That's our schema. Next up, I will create our post search database using this new schema. And let's just drop some animations in. I'm just going to drop all of our crouch animations and a crouch idle. Let's pick this one. And one more thing I'm missing here is I haven't assigned the animation blueprint. So let me swap that out quickly. Excellent animation, right? So what am I missing here? Clearly, I did not assign my post search database. So let's get that on. There you go. And just like that, we have our character running around and using this, you can see bugs, that's the 30% that I was talking about. And right here, I'm going to draw our motion matching query. And you can see when I'm moving around, this is what the game wants to do. So we're picking animations that match the feet and that match our game's trajectory. So with that out of the way, let's dive into the game animation sample and its setup. So in the game animation sample, we have a character that can run around and can strafe. Strafe is usually what you see in a game like Fortnite, shooter games in general. I have all of my nice transition, boxes, starts, stops, pivots. I can also change my character to be forward-facing. This is closer to what you'd see in an action-adventure game. We also have seamless transitions between the two. And our character can also jump. And we can do traversal, but I'll get to that later. So what I want to show you here, since it's not a very long talk, there's a live stream that we did that was 3 hours long. We go a lot more into detail over how you debug individual things. I just want to show you how we tend to like working with our animation systems and how we make sense of it, debug it, and whatnot. So your best friend is the rewind debugger. When you launch that rewind debugger, do yourself a favor, enable these two. This will make it auto-record every time you press play and also auto-eject, which is something that you want to do all of the time when you're debugging. Let's just select our character, hit record, and time to walk around. With Rewind Debugger, now I can just scroll through and see exactly what my character was doing and why. Right here, you can see all of the animations that we were selecting, and you can see it's multiple animations that are blending together. And I'll show you, like I rarely use Content Browser these days for debugging, and that's because I can just go in here, double-click my asset, and there you go, this is my graph. What's interesting about it is that I can also use Rewind Debugger to see the current state of my graph at that point. But I'll get more onto that later. Let's talk about the difference between the minimal setup and the 100% setup. This is the post history node. And we've also specified which bones we care about to collect our post from at this point in the graph. We're sort of like taking a snapshot. Different from the base setup, we also care about the position of the thigh, the spine, the pelvis, and we use that to do the nice transitions and turns. You'll also see that we're no longer using the automatic trajectory generation, and that's because what that last 30% about is sort of getting away of the black box nature of motion matching and give control to your artists or designers to do whatever they want to do with it. Motion matching is just a tool. Over here, we generate a trajectory, and our trajectory generation has a lot of values that we can use to control how our trajectory blends towards the desired input. This is all capsule-driven. It's using default character movement components, so sometimes your data is not perfect. Motion matching, if you have all of the animations in the world, motion matching is perfect, but if it's not, or if you have multiple animations that do the same thing, then you end up selecting the wrong thing. So we kind of want to trick trajectory a little bit. So what we realize here, for idle, that means for our turn-in-place animations, we wanted it to be differently than when we're moving around. So we just use gameplay blueprint-driven logic to generate our trajectory differently. Then we can do a post-process step on our trajectory to use collision information, and that gets us our really nice arcs for jump matching and also for falling off a platform. And this is the part I wanted to focus on specifically. By exposing post history to the rest of your animation systems and even your game, well, then you can query your trajectory for different purposes that are outside of motion matching. In this case specifically, we grab 2 future points in the trajectory in time, we find the difference, and with that, we can detect the velocity at a future point. And you can see how that can be useful to know, am I going to be moving in the future? Am I coming to a stop? We just use it in different places. Let's go back to the graph and ignore all of these layers of complexity and go straight into the motion matching node. Like I was talking about before, controlling motion matching is about having configurable values that can adapt based on what your game wants to do. In this case, an example of that is our motion matching blend time. Let me open that up right here. Right here, you can see that based on what our movement mode is, we might want to blend differently. We might want to make our transition snappier. We might want our blends to be smoother for that specific context. For now, we're doing it like this, but in the future, we want to add new features so that you can, pretty much like a state machine would do, if you're going from a specific animation to another specific animation, you can have specific blend times, or maybe we can transition from one specific database to another. Next up is about how motion matching communicates with the rest of your system. We have this new anim_node function in 5.4 that's called onMotionMatchingStateUpdated. It runs after motion matching grabs its selection. So you can grab the motion matching state and use it for various gameplay logic. For example, if you have a play rate and you want another animation to play at the same play rate or start at the same time, you can do that. In this case, we grab the database, and the database tells us whether we're in a state or not where we want to do some other specific graph logic. An example for this might be that maybe you don't want to do orientation warping for this particular database. You can use this to run that logic. Now, let's look at which database we're using. And if you've looked at the sample, you'll see that we don't have a database selected here. And that's because we're not assigning it statically, we're assigning it dynamically. We're using one of my favorite features. It's not new. It's in beta in 5.4, which is called choosers. Choosers are basically a general purpose data table where you have a selection, a result on the left, and criteria on whether or not you want to select that. Choosers have different ways of outputting an option. You can say, give me the first one that matches this, or you can tell it, give me all of the results that match this criteria. This is very useful for selecting motion matching databases. Let's go back to Rewind Debugger now. And let me find my chooser right here. This is the one I want. Choosers are fully integrated with Rewind Debugger. What that means is you can see it on my recording. It can tell me what it selected at that point in time live. So let's look at our runs. You can see here that we have multiple motion matching databases. And I'll explain why this is very important for that 30%. Motion matching does its best estimate on what animation it should select. But sometimes gameplay has to be very snappy. In Fortnite, we really cared about responsiveness of the character. So we separated our motion matching databases into multiple ones. It wouldn't matter if motion matching decided, no, I don't want to play a start animation. If my chooser said, I want to search the start database, then go ahead. And that made sure that the very frame that you pressed move, then your animation would pick, motion matching would select an animation that moved. This was the same case for pivot, starts, and everything else that you see here. I encourage you to dive into this yourself and look at all of these different databases. Now, another thing that was a powerful result of separating our databases into multiple ones was that we could have multiple schemas. Just logically speaking, you may care more about the position of the feet when you're running, but you may care about it less when you're jumping or when you're doing something else. In this project, like tuning a schema is a very artistic process in the sense that it's a skill that you learn. There's no mathematical perfect way of picking up your perfect schema. The best way to learn is through experimentation. So I encourage you to try your own values and see what works best in your gameplay context, and to look at our schemas to see how they're different from each other. Next up, I want to talk about the post-search debugger. The post-search debugger really is a tool to make sense out of why you're selecting something. You can see this will update as I move to different points in my animation selection. I can see different scores. Usually, you want to find the exact place where you transitioned from one animation to another. So right here, let's go. The frame you want to identify is when you see your start or your idle go to something else. So right here, I'm on a stop, and I went to a start. And let's figure out why. Well, really, the main thing that you care about is this exactly right here, the cost. And I actually think I picked the wrong animation, so apologies for that. I'll find a different spot. Yeah, this makes more sense to me. So let's talk about the continuing post. The continuing post is one of the most important things to understand how to debug motion matching. Continuing post is what would have motion matching selected if I did not change animations from my previous selection. The continuing post is right here, and you can see this is its score. And then right here, you can see the active post, which was the animation that beat the continuing post in score. It's very simple. You have a cost. This one had a better cost. You pick that one. I could have picked any of these options that had a lower score than the continuing post. In this case, I picked this one over here. And when you really want to deep dive into what specific parameter of my schema is what gave me this resulting score, you want to go to channels breakdown. And then you can see for every single channel that you have, and for every single channel that you have, and for every option or variation that you have in there, you'll see how much cost that contributed to your current selection. But let's talk about the 30%. The 70% is about finding a schema that works out for you. And one of the problems with motion matching is that you might get really late into development, and you're not getting the selection that you wanted in this specific scenario. And you're really scared of modifying one of your schema values because it's going to affect the selection of that whole database entirely in your whole game. For that, we added a variety of anim notified tags that you can use to sort of hint post-search into, I prefer this animation. So I have a good example captured right here. Let me find that refacing turn that I played before. This one right here. So refacing starts, I think they're cool. And I think that when games do them right, they look really good. And if your game has them, you should show them, right? In this case, our animator realized, well, I don't really care too much if my game's trajectory doesn't match what the turn is doing. As long as it's roughly on the same area, I want to pick that animation. So all that our designer had to do, what's this right here? They added a tag called post-search override continuing post bias that just says, prefer this animation even if it's not that good of a match. And really, this is how you fine-tune your system, and you go into different animations that you really like and that you think are really cool, and you bias selection there. Or if an animation is not picking as consistently as you want, add more tags. There's two other ones that we use here. This one is the exclude from database. That means never search this part over here. And the other one is the post-search block transition. This one means I do want to enter this part of an animation as long as I am transitioning from a part that is valid into this, so I want to transition out of this, but I never want to transition into this. Now, let's talk about Traversal. As you can see right here, our character contextually picks the best animation for this particular scenario and based on current gameplay state. If I'm running, I will play a running traversal. If I'm standing still, I will play an in-place traversal. And if I'm walking, whoops, I'll play a walking traversal. So, going back to the 30% concept here, we're not letting motion matching do all of this for us. There are ways where you could feed all of this information into the motion matching system, and you may get something really good out of it. But at the same time, well, if my designer wants to play a specific kind of animation for this specific kind of obstacle, let's just let it happen. So let's look at how this setup works. Well, it's this right here. We're just using montages. And yeah, we pipe this somewhere else, but this is essentially the same as a montage play. Let me draw this right here. This is the same as having a montage play where you plug in all of the results of your selection right into it. There we go. This is a motion match montage. So we added this blueprint function called motion match because we honestly do not know and do not want to presume that we know in which context a user might want to run a motion matching search. We isolated this to a simple motion matching node that you can call from anywhere that you want. You give it a list of assets that you want to search. You search them. It gives you a result. Do with that what you will. Now, let's go back to a rewind debugger version of this. When you're debugging motion matching, you want to find what frame you started to do a search, you want to look at these lines over here. And this is a spike right here. You can see it. So that means this is the frame where the search happened. Let's open rewind debugger details again because I closed them. And because we're doing multiple searches on this same frame, we're doing one for the montage and one for the locomotion. Let's select the traversal one. So right here, there is a database. And our database has all the possible selections that we could have picked for traversal. But this is not entirely true. If we look at our post-search debugger, you'll see that the options are actually not many. So let's dive back into our blueprint that we saw before. And look at what the chooser is doing. Again, since this is live debuggable, we can see exactly what was happening. We have gameplay logic that defines whether it's a hurdle, a vault, or a mandel, and that depends on the obstacle type. We had a very simple spline-based detection system for what kind of traversal you were going to do. We've seen other people in the community do this entirely dynamic. This is really up to your game. So it is a hurdle. This is a nested chooser, so that means we can have a chooser within a chooser. And let's see which animations pass. And it's, well, just two of them. Only these two passed, and they are the left foot version of a 1 meter hurdle and the right foot version. So that's it. We only ran motion matching on two animations. And I'm going to introduce you to another type of tag that we have, which is the post-search branch in. This post-search branch in lets you entirely within your asset define a window that you want to be able to match into. This is really nice for actions that are discrete, like a montage. Then we have a post-search database, which is the same database that we saw before. And that's basically it. This means that when I play this particular action, I can match any of the frames within this window. And from there on, this is a regular montage. If you're familiar with the motion warping feature that has been around since 5.0, you just use those together. Like I said, motion matching is a tool. You can use it in the context of our whole ecosystem. It is not its own thing. But you'll notice something different about traversal animations. They have this point right here, which represents a bone in our source animation, the attach bone. This was a way for our animators to specify this is what the edge of the traversal action is. And that brought in an interesting problem for us, which was how do we communicate to the game what this ledge is in a gameplay context? Well, it's very similar to trajectory, but we wanted to give something more extensible to our users. If we open the schema for traversal, we'll find a special channel, these two special channels. These are blueprint channels. We give you the ability to override the logic on any of your channels to feed your own gameplay data into your search. This is used at query time. So when you build a query, that means the current gameplay state. You can say the current gameplay state is that the edge of the obstacle is right there. And let's find that feature, that channel. It's very simple. Any feature has access to our anim instance, and then we can just grab this data from our anim instance using this interface. That same way, when we do our traversal, that means when we do the traces in the world or we detect an edge somehow, we can just say set interaction transform on our anim instance. And that's pretty much it. That is traversal. It is regular blueprint logic. Now, I want to talk to you about something new in 5.4, which is called blend stack. Right here. So for those of you that had already looked at this, if you double-click a motion matching node, you will go into a graph that's inside the motion matching node. This is a graph that runs individually for each animation that motion matching selects. This means that we can warp our animation without without using the blended result. We can just do it per animation. Essentially, it works like a state machine. So if you're familiar with state machines, it's pretty much like this. Your motion matching selects an idle, then it selects a run, then it selects a stop, and once it runs out of graphs in the blend stack, this one goes away, and it's your new graph to run. We offer the blend stack node in different ways in 5.4. You have a regular blend stack node that you can use to give any animation asset that you want, but we've also used it for something called the chooser player, which is basically a special kind of blend stack where this animation asset is the result of a chooser search that happens entirely within the node. We encourage you to try this out and use blend stack in your own kinds of nodes. Now let's look at what we do to each one of the animations that we've selected. We use the classic orientation warping. If we select a run north and we're going at 45 degrees, we want to warp our translation by 45 degrees to reach our target. Not all of our animations are okay to be warped in the same way, and certain portions of the animations, maybe corners of a pivot, we don't want that. So we added this option here, which lets us grab the current selection for this particular graph of animation sequence, and then we can grab a curve from that animation and say just disable orientation warping. there's a new experimental node in 5.4 called steering. What steering does is it works with rotation. We reorient the character to match the desired facing that the player, that gameplay requests. Like I mentioned before, by exposing trajectory to gameplay systems and to anim blueprint in general, we can calculate our desired facing really easily. We just grab our trajectory, we look 0.5 seconds in the future, and that's it. If you want to have your blend be like more instant or longer, you can tune around values of where you're calculating your desired facing from. Steering also has internal interpolation, so you can play around with those values. We found out that we wanted our turning places to behave differently from our forward-facing animations, so we run these two over here. Like I mentioned before, you can use your currently selected database to do graph logic. In this case, databases that have the tag of turn in place, well, those ones use this steering node. And the ones that don't, they use the other one. And to show you what the turning place looks like, this is it. Now, let's talk about the fourth point of what the game animation. Wait, I forgot about the most important experimental node of why steering and orientation warping work. It is the offset root bound node. When you use orientation warping or steering, you're generating root motion tracks. If you're familiar with the old school root motion system, root motion does not flow through the graph. It runs as a step before animation, so you don't really have the opportunity to warp your animations individually. By using this root motion attribute, we can warp the root motion in each one of our individual nodes, and then consume that root motion right here with offset root bound. Offset root bound is represented by this debug view, where the circle represents how much translation can deviate from your character. This is not the perfect ideal way, because this means that using this root motion offset, your character can come out of its capsule. This is most easily seen when I run into a wall and my mesh clips into the wall. There's multiple ways to solve this. We can reduce the offset when you're near a wall, or we can trace against that on the movement, or we can even have a better trajectory. Like right now, our trajectory does not collide against the wall, so it gives us an animation that wants to run towards it. In future releases, we will improve the trajectory generation so that we can have a nice curve that goes around the wall and actually represents what the character wants to do. We have better selection. That means there's less offset, and your quality will be higher. Root offset is also completely optional. You can disable it, and your match will be good enough. It'll just be a little bit more slidey because we don't have foot pinning, and also you're no longer offsetting the character with root motion, so that means your movement model and your animation may not always match. Now, I will give you a sneak peek of 5.5, and if you've been following UE5 main, you might already know of this. But the root motion attribute is interesting to us because, well, ideally, this is how you want root motion to work. You want it to flow through the graph, you want it to be able to warp it, and use it for actual root motion of the character instead of the legacy system that we have right now. Sorry for the bad frame rate. The sample released a week ago, so we haven't had too much time to do this that I'm showing you now. But this character right here, it's running 100% root motion using the new root motion attribute and significantly more efficiently. This might not be what you want for a multiplayer game, but if you're looking for a single-player, high-quality root motion character, it's really worth giving that one a try. The biggest benefit that I saw was in refacing turns, like this one. They're perfectly planted because we're using root motion. We're not reaching the edge of our offset, and we're not pulling the mesh along with the capsule. And now, let's talk about the fourth point, which was, how do we bring our own characters into this? How is this flexible? How do you use it with your own projects? You'll notice this Nice widget that one of our designers did. Oh, and I'm T-posing. Interesting. Start this again. There we go. So we're using runtime retargeting to select any character that you want. And we have a bunch of characters that we use in our own projects and that we released in multiple samples. I'm sure you have your own characters. And we wanted all of them to work with the game animation sample. We have the UE4 mannequin. A ton of the assets in the marketplace use this mannequin, so we wanted it to be compatible. We have Echo from Valley of the Ancient. We even have a Paragon character, and our retargeting tools were solid enough to make this work on all of them. You can see that hand contact points are still correct in all of these characters. We also have metahumans. And we've tested this on every body type of metahuman that you might think of. Contact points still work. If you want to evaluate the quality of your retarget, you can have different characters side by side. The native character is the one in the middle. The other characters are full retargets. Now, I'm not going to dive into how to use runtime retargeting in this talk. The reason for that is runtime retargeting has been available for a while. And now we have a place where we can try it for you. We can find a lot of issues, or some issues, that runtime retargeting has, and we can improve them for you release after release. So we encourage you to try your own characters and see what problems you find. And now I'll address the other elephant in the room, which is, well, you don't want to use runtime retargeting in all of your games. You might just want to use our animations as is. For that purpose, runtime retargeting allows you to retarget your animations to any skeleton offline. Let me find one of those assets. Here's our retargeter. Here's our mappings. And here we can see how different animations work and the quality of their retarget. Now, using this tool, you can do a one-click conversion of all of the assets. I don't want to convert all of the assets, so I will not do it. But we have it in the documentation, and you can try it out. The problem here is that now you need to rebuild your animation blueprint in all of your for any of your new characters. And that's not really something we want you to do all of the time. In future releases, we will improve the flexibility of this system and make the process of transferring and making native animations from your sets to your game like smoother. And now let's talk about the future. First is root motion control. I already showed you, now we have a fully root motion-driven character that can run in the game. But that's not really what you want in most projects. You may want your loops to be capsule-driven, and you may want your starts, pivots, stops to be fully root motion-driven, or maybe in between. We're working on technology to be able to blend between root motion and non-root motion approaches in a way where you could say, I want 70% of capsule-driven, 30% of root motion, or I want to author a really fine curve over which parts of the animation are root motion and which ones are capsule-driven. Next up is animation stitching. This is a new technique that we're going to be building on top of motion matching. The idea is simple. Instead of working by providing desired game context, you can provide more complex game context to your motion matching search. That means if you have a fighting game and I want a punch to land on the face 0.5 seconds from now, I will do a search that will get your fist right there. That is motion matching stitching. Then, multi-character motion matching. Same example as a fighting game, or if it's two characters walking around holding hands, you may want to do a search that doesn't just include features of one character. You wanted to calculate features for both characters. This also includes more things like dependencies between characters, and that is something that we will include in a future engine release. We're working on it. And it's looking pretty cool. No video here today, though. Sorry. And then, trajectory generation tools. Remember how I was mentioning that we're using trajectory for gameplay? We want to really empower users and give you easy ways to do trajectory analysis and tell you what the game is currently doing. On top of that, we want to rewind debugger to be able to record your root motion and then allow you to deterministically do changes in your motion matching databases and preview your new matches live without having to rerun and re-record your game. Next up is better tools for source data matching. That one's very important to us. Motion matching may have lots of animations, or you may want to do a new one for a new move that your character is doing that might have a specific trajectory. Leveraging animation in engine tools will provide easy and smoother workflows to transfer game root motion over to live animation editing, so you can match your animations to the new trajectory of your game. And finally, usability improvements. We promise you, and we are committed with every release to improve our animation toolset. We're listening to the community. We are watching comments on the live streams. We're looking at you on the forums. We're looking at your UDNs. We care deeply, like our team cares deeply about the game animation sample, and we want to make sure that you care about it too. So if you see any problems, please tell me about them, and we will look into them. And we will fix and improve and add features that we need, but also the ones that you need. And we can't know that unless you tell us. That's it for the game animation sample. Thank you very much. And we have time for questions, so if you have any questions, I will answer them now.